Hi guys, today is December 17th and the problem we're working on is for-sum variation number 2. So we're given 4 lists, A, B, C, and D, and they contain integers. All 4 lists have the same length. We want to figure out how many combinations of I, J, K, and L such that if they were the indexes into the list A, B, C, and D, the sum of all 4 values is 0. Let's look at the example that's provided. We're given 4 lists. They all have the same length. They each have 2 values. And we want to find all the combinations of I, J, K, and L such that if I was indexed into A, B, index J of B plus index K of C, and finally index L of D, we want to find all the combinations of I, J, K, L such that this sum adds up to 0. So we can do this by splitting up this sum into 2 parts. So in order for these 4 numbers to add up to 0, that means that the first 2 values needs to be the negative of the sum of the second 2 values. So let's look at all the possible combinations of sums that can be produced by the values in A and the values in B. If we sum 1 and -2, then we get -1. So we can keep a dictionary, keep a key, -1, and a counter of 1. And then if we sum 1 and -1, then we get 0. So we get 1 pair that gives us the value of 0. And then we can sum 2 with -2, and that's a sum of 0. So this counter of 1 gets incremented to 2. And then finally, if we sum 2 and -1, we get a positive value of 1. And that only has a count of 1. Similarly, we can come up with all of the sums that can be produced by the values in C and D. -1 plus 0 is -1. So we have 1 pair that gives us -1. -1 plus 2 gives us +1. So 1 value of 1. And 2 plus 0 is 2. So also 1 value of 2. And then finally, 2 plus 2 is 4, and we get 1 value of 4. Okay, so if A and B sum up to -1, in order for the entire sum to sum up to 0, then the sum of C and D must be +1. So we have 1 pair of A and B, and then 1 pair of C and D. So that gives us one combination of A, B, C, and D values. Okay, if A and B sum up to 0, that means C and D must also sum up to 0 in order for the overall sum to be 0. And we don't see a sum of 0 here. And finally, we see if A and B sum up to 1, then the C and D values must sum up to -1. And we do get one of those pairs. So then this is another 4 values that can sum up to 1. So we have 1 plus 1 equals 2, and that's why the answer is 2. The problem is simplified in that A, B, C, and D all have equal lengths. So we can set n to represent the length of the arrays. And we can iterate through all of the numbers in A and B to find out all the possible sums between the two. So I'm gonna initialize an empty counter, and then I'm gonna loop through. I'm gonna use I to loop through A and j to loop through b. And I'm going to increment the key in the counter is going to be the sum, and the value is going to be the frequency of that sum between the values of a and b. So we're going to do plus 1, and then similarly we're going to declare and copy this and declare a second counter. And instead of I and j, for clarity, let's rename this to k and l, and then we're iterating through c and d, k and l, and this is counter number 2. So counter number 2, the keys are going to keep track of all the possible sums that can be produced from the values in c and d, and then the first counter is going to keep track of all the possible sums that can be produced from the values in a and b. And then we can iterate, we can check all of the keys in the first counter. And if there's a corresponding value in the second counter, so if the second counter has the negative of that key value, then we can, so we're gonna store the answer in an integer. So it's gonna start out at 0, and for every sum of a and b, if there's a negative value, negative sum in c and d, then the sum of all 4 numbers will be 0. So in that case, we can increment the answer by by the frequency, by the counts of how many pairs have that sum, multiplied by how many pairs of values in c and d have that sum. And finally, we can just return the answer. So we run our code, that finished, and we submit. And it was accepted.